equations, part 1. So in this video we'll just go over types of ways we can solve linear equations. There are other videos on this, but this is just an introduction. So anyway, what is a system of linear equations? It's a collection of two or more linear equations. That's what a system is. So linear equations have the same variables. They have to have the same variables in a system of linear equations. So let's just look at a visual. If we have two equations, two linear equations that meet, here are two systems. And where they meet is the solution. So right here the solution would be 1, 3. 1, 3 would be the solution to these two equations. So wherever they meet is the solution. And it doesn't have to be two equations. You can have 3 equations or 4 equations. So here you can see they're all meeting here at 1, 1. So that would be the solution. And there are many ways we can solve systems, but let's look at one right here. So here we have y equals 2x plus 4, and we have another one that says y equals 4x. So when we do a system of linear equations, we can put a brace in, showing that this is a system. So these two equations will either meet or not meet. So there's 3 ways we can do this. We can solve it. We can solve it by graphing. Graphing could be the easiest way, depends on the student. It's also a longer way. There's the elimination method and the substitution method. So there's 3 ways we can do this. So let's look at graphing real quickly, and there will be another video on this. But we have these two systems here, and we want to see if they'll meet, if we have a solution. So again, remember, with a system, the x and the y for both of them have to be the same. So we can graph this. So we can put this here on a graph. And let's look at the first one. We'll just put up here y equals 2x plus 4. So let's graph that one first. And you can make your own domain and range box. So if you make x 0, for example, if x is 0, then y is 4. So there's the first one. Put a dot there. And then we can do a couple of others. So if x was 0, y was 4. If x was 1, y 6. Right? And now we know the slope is 2. And we know the y-intercept was 4, so it had to start here. So we're going up 2 and over 1 each time. Up 2 over 1. Need a better marker here. And we're also going down 2 over 1 each time. Okay, so we have roughly a line going like this. So there's one line that we graphed. Now, let's use another color. And let's graph the other one. So here we have y equals 4x. Right? So we know that there is no b, so we know it's starting here. When x is 0, y is 4. X is 0, y is 4. When x is 1, excuse me, when x is 0, y is 0. When x is 1, y is 4. Okay? When x is 2, y is 8. When x is 3, we're off the map here. So you can see our line's going like this. We already know where it's going to meet. They're meeting at the 8. But let's do another one. What if x was negative 1? If x was negative 1, y is negative 4. So we have this line here. And it's going this way. So they're crossing at 8. That's where the solution would be. So the solution here would be 2, 8. Now how can we check that? Well, let's plug in x for 2. What's 2 times 2? 4. 4 plus 4 is 8. Let's put 2 again in. What's 4 times 2? 8. So they both have the same variable. That's the solution, 2, 8. So we could have done that by graphing. We could have also done it by the elimination method. Now with the elimination method, we want to eliminate one of the x's or the y's, either the x's or the y's. Now actually with how this is set up, it's actually easier to do the substitution method, but let's do the elimination method now just to give you an idea. So let's say, how can I cancel the y's out? With the elimination method, we're going to take both equations and add them. But if we add them, we won't eliminate anything, because y plus y is 2y. That doesn't help us. But what we can do is if we change the y to negative, we'll have to change everything to negative. Now y plus negative y cancels out. So we're left with negative 2x plus 4. So we have 0 equals negative 2x plus 4, because they cancel each other out. Okay? Let's bring that up. So now we want to find, we're going to minus the 4 on both sides. Now we have negative 4 equals negative 2x. We're trying to find what x is. I'll bring that up so you can see it. There we go. Divide out the negative 2 on both sides. And here we can see now that x is going to equal 2. Okay, now that we know that x equals 2, let's plug in 2 for x. What's 2 times 2? 4. 4 plus 4 is 8. What's negative 4 times 2? Negative 8. Negative y is negative 8. So regular y is regular 8. We'll do a lot of the elimination method in another video. I was just giving you an introduction to it. Now here's the substitution method. This one's easy when you see in slope-intercept form. So here, we're saying that y equals 2x plus 4. And here we're saying y equals 4x. So instead of having y now, I can substitute the 4x, because y equals 4x. So I can say 4x instead of y equals 2x plus 4. We could have also had 2x plus 4 equals 4x, because we know what y is. That's what we do when we substitute. Okay, so I want to minus the 2x on this side. Whatever we do to one side, we do to the other. And we have a 2x equals 4. Bring that up. Trying to find what x is. Divide out the 2 on both sides. We know x equals 2. Now that we know that x is 2, let's find y. What's 2 times 2? 4. 4 plus 4, 8. Let's see if it works for the other one. What's 4 times 2? 8. So just like when we graphed it, our answer is 2, 8. That's the substitution method. Let's look at a method we can do with elimination here. So both of these are in standard form. So again, we want to either get rid of an x or get rid of a y. And when we eliminate, we're adding. Right away, we can see a negative 6y and a plus 6y cancel each other. So now we have 8x, and here we have negative 32 plus 48, and that equals 16. Remember, I canceled the y's because a negative and a positive will cancel. So if I divide the 8 out on both sides, I know that x equals 2. Now, I need to find what y is. So take the 2 and put it into the x's, any x you want. Let's check the first one. 5 times 2 is 10. 10 minus 6y has to equal negative 32. We have a positive 10 here, so we're going to minus the 10 on both sides. Minus the 10 on both sides. Gets a little messy when you do these. So now we have a negative 6y equals a negative 42. Divide out a negative 6 on both sides, and we have y equals 7. So our solution should be 2, 7. Let's see if it works for the other one, this one. So we're saying that x is 2. So 3 times 2 is 6. And we're saying that y is 7. 7 times 6 is 42. 42 plus 6 is 48. It checked out. That was using the elimination method. Now again, if you're getting a little confused, rewind the tape, but we'll do these in individual videos. I'm just introducing you to the type of methods we can do. Something you should know is that when in system of equations, you can have an infinite solutions, you can have one solution, or you can have no solutions. So here, what we've been doing, we've had one solution. It's 2, 7. That's what it is. It's 2, 7. It's one solution. Sometimes you can have infinite solutions. Let's look at this. Here we can eliminate. Remember, with elimination, we're adding them together. 2x plus negative 2x cancels. Negative y plus y cancels. So you're left with 0. And 3 plus a negative 3, that was supposed to be negative 3, is 0. When you have 0 equals 0, you have infinite solutions. Because you can make the x and the y anything. Again, remember, this is very important. When you have 0 equals 0, you have infinite solutions. Keep that in your head. 0 equals infinite solutions. If you have no solution, then you have parallel lines. Parallel lines have no solution. They don't meet, right? Two lines, they don't meet. They do have the same slope, though. Keep that in mind. But they don't meet, so parallel lines have no solutions. Now, if you have one solution, they'll meet somehow, right? Like that. But if you have one line, let's say you have one line, and then there's another line on the same line, well, that's infinite solutions. So this is just an introduction to system of equations. We'll do more in part 2.